We are going to work on the correction of all the exercises there, and it says, first of all, calculate the measures of the missing angles. This is something you know, and we are going to begin here. 53 degrees. We have this clue. The idea says we have a transversal going through or intersecting two parallel lines. And so we have everything we need to make the calculations. 53 degrees, that angle is vertically opposite to x. It means x is 53 degrees. Why? Because they are opposite, because they are vertical angles. Intersecting lines form vertical angles which are congruent. Remember that. Now, we say, okay, besides that, 53 and W are adjacent angles. Yep. And they are adjacent in a straight line or a straight angle, you can call it. And so it means 180 degrees from this point to this point minus 53 degrees is what? Well, is W, right? The value of W. And it means, well, we are going to subtract over here. It says 10 minus 3 is 7, and 7 minus 5 is 2. And so we have 127 degrees, which is W. That is the angle W. All right. Now, because it is a transversal, intersecting two parallel lines, we can tell this angle is congruent to this angle. And because they are parallel, these two lines are parallel, we are going to tell, we know this angle is congruent to this angle. And so this one is also 127 degrees. How come? Well, W and Y are congruent because they form the same angle. This transversal forms the same angle as these are parallel lines. Okay? Once again, it is properties about. Now, let's keep on going and let's find Z, angle Z. Over here, we already know angle Y, which is 127. And we can tell because of this sign, because of this symbol, because of this graph, it is 90 degrees. So we know 127 plus 90 degrees. Now this is going to be 7, this is going to be 11, and so 217. But is that the angle Z? Nope. We can tell this is a circle. Angle Y, angle Z, and angle, which is 90 degrees, form 360 degrees. So 360 degrees minus 217 is the value of Z. So we say this is 3, 5 minus 1 is 4, and this is 1, 143 degrees. Isn't it? And that's how you find the value of the missing angles. It is about properties that you know that we had studied. Okay? Now we are going to make it a little bit greater. That's it. And we are going to read exercise 2. The given pentagons are congruent. Find the missing values. We are going to, well, we know they are congruent, and we are going to see this corner. It says there is an angle of 90 degrees, and there is no other angle, there is no other intersection which shows me this symbol, and so I can tell these 5 centimeters over here are these 5 centimeters over here. It says that, yeah? It says that, so it's a super clue. And so the value of x is that line segment, which is right there next to my 5 centimeter line segment. Yep. And it tells me the value of x, 3.5 centimeters. We have to place the unit. No unit? Well, it lowers your punctuation. What about y? Well, this is angle y. And so we say this is x, line segment x. This is line segment, which is 5 centimeters. We're going like this. And it tells me that I arrived to angle y, right? How much is it? Because they are congruent shapes, they have the same measurements. And so y is 119 degrees. Yep, that's it. Z, I don't have to do any calculation. I only have to compare my two pentagons, my two shapes. That's it. And what about Z? Well, angle Z goes like this. Is the next one, yeah, the next line segment there, if I am moving, well, this way. And so angle Z is, it's not an angle, it's a line segment, is 4 centimeter, yeah, 4 centimeter long. Got it? Yep. We only have to make connections. We only have to see the figure rotated 90 degrees. Yep. Because you can tell these 5 centimeters over here are vertical and this is horizontal. It was rotated 90 degrees, yeah, counterclockwise. Oh, now we are going to work on exercise 3. It says use a protractor to measure the given angles. They want us to measure angle 7 and angle 2. Angle 7, this is angle 7. Notice that it goes from this side, yeah, and this other line, yeah, which is a transversal, yeah, but for our angle is just this over here. Okay, that's angle 7. And they say we want to measure angle 2, yeah, which is over here, and this other arm. They are the arms of my angle. This is one, and this is the other arm of it. Okay, now I need a protractor, so I am going to come here, in which I have this protractor. You can find it in an extension, in a Google extension that is called protractor. No surprise. No? And then I have the protractor, this beautiful tool. And what I want to do is to match this very center of my protractor with the intersection there in my angle. Well, the angle I am measuring. Let's go for angle 2. So I am going to place one of the arms of my protractor here on the horizontal line, which is one of the arms of my angle 2. And I want you to look at the number which is there near the center. Yeah, it is changing. Now it is 31.6. Now it is 46.1. Yep. So that is the angle I want you to take a look at. I am going to move the arms of my angle, well, of my protractor, and I'm going to place it here. You see that it says 130.2. Yep. Because I am using the mouse to move the arms of this angle, this protractor. I cannot be that precise for it to measure exactly 130, but basically that is what you were measuring there with your physical protractor on your paper. So this is 130, right? And that's what we are going to write there for angle 2. Now we are going to measure angle 7. So we are going to place it here for the intersection, matching the very center of my protractor. And I am going to go for the transversal. Yeah. And now I take the other line to match the horizontal line. Yep. Well, I'm going to go like this because now it changed the angle. Okay. I want you to look at this time the angle, or well, the number, which is not next to the center or closer to the center, but the one that is below. And you're going to see that it says 130.4. And I don't want to keep in mind this one because it's the outer angle. This outer angle, now which is 229, well, actually 230, yeah. And the inner one, which is angle 7, is 130 degrees. Yeah. We see the number 130.4. That is angle 7. So once again, because of my mouse, I cannot be that accurate. But anyway, with your physical protractor, you were measuring for sure 130 degrees. So we can tell angle 7 is 130 degrees, and angle 2 is also 130 degrees. And it says, what can you explain about these two measurements? Well, what we want to see, what I expected you to realize is that these are two parallel lines and this is a transversal, and the property says these 3 and 2 are opposite angles. Number 7 and number 6 are also opposite, vertically opposite. It means they are congruent. So 7 and 2, angle 7 and angle 2 are congruent, This is what I was expecting you to write. They have the same size. They measure the same. They measure the same. Okay? This is exactly what I was expecting you to write. Yep. We cannot tell angle 2 and angle 7 are vertical angles because they are not. Angle 2 and number 3 are vertical angles. They are opposite, vertically opposite. Yeah? And so is 6 and 7. But 2 and 7 are not. Yeah? They are congruent because of the property. Okay, we are going to work on exercise 4 now, which is about definitions. We have some definitions here. It says vertical angle. Angles are vertically opposite when they are placed in a transversal line intersecting two parallel lines. Their property is they have the same measurement. So we once again say angle 2 and angle 3 are vertically opposite. Yep. We could say angle, which is this one, which is 53 degrees, and this one, which is x, they are vertically opposite. Why? Because there is a transversal, yep, going there. Well, there are actually two intersecting lines, right? So they form vertical angles. So, of course, you can have different definitions as long as you explain what it means, right? So this is not a very unique one. Now, symmetry. I found this in Cambridge Dictionary. It says the quality of having two parts that match exactly, either when one half is like an image of the other half in a mirror, or when one part can take the place of another if it is turned 90 degrees or 180 degrees. Well, I like this definition. However, I placed my own and I say it is a reflection of a figure over an axis so that it is congruent on both sides. Yep. Perpendicular. Two lines are perpendicular when they intersect, forming a 90-degree angle. Yep. Isosceles. It is a triangle or a trapezoid with two equal sides. Yep. Trapezoids can also be isosceles trapezoids. Counterclockwise, when measuring an angle, moving in the opposite direction to the movement of the hands of the clock, going like this. Yeah, you're moving in the opposite direction of the hands of the clock, and that's it. Well, figures with the same shape and size, that's congruent, right? So two shapes are congruent if they have, well, two figures, if they have the same shape and size. Prism. It is a solid with a cross section. Cross section. I want to make emphasis about, I want to come here and remind you of this exercise. This is a polygon, right? It's 2D. But once it becomes 3D, we say the 3D object is in this case a rectangular prism, and it is a prism because it's a solid that has cross section. What is a cross section? In this case, is a rectangle. However, we can have a triangular prism, or pentagonal prism, whatever the side. So the cross section is given by a polygon, right? And so the name of it can be a square prism, cube prism, triangular prism, pentagonal prism, and of course many others. Well, then we have radius, which is any line segment going from any point in the circumference to the center of a circle. So I just want to go like this, and we can begin in any part of the circumference, and it is going to be the radius. What a horrible circle. Then it says volume. It is the space inside a solid. So, and polygon, it is a 2D closed shape with the straight lines. And that's it. That's the meaning of polygon. We want to move there for challenging situations. So this was asking us to draw lines of symmetry in each one of the shapes. So I want to go like this. Of course, it's not getting that straight, but let's say that this half is congruent to the other half, right? So they are symmetric. And then there is 1, there is 2, 3, 4, and 5. And then I am going to say there are 5 lines of symmetry, and the order of rotational symmetry, I want you to check this out. Well, where is the... Okay, over here, I'm going to go like this. I'm going to say that it matches 1 time, and 2 times, and 3 times, and 4 times, and finally 5 times when it goes back to its original place. So the order of rotational symmetry is also 5. Now, it says, state how many there are in its order of rotational symmetry. Well, that's it. And it says lines of symmetry, only 1. Yep. Order of rotational symmetry then is only one, right? It says lines of symmetry. There is one and there is two. So what about the rotational symmetry? Order of rotational symmetry, it is going to match 2 times. And we have this, which is one line of symmetry. And the order of rotational symmetry is also 1. Yep. Now, we want to go there for these exercises. It says a rectangular prism has a volume of 693 cubic centimeters. The prism has a width of 9 centimeter and a height of 7 centimeter. What is the length? What we want to keep in mind is a prism, well, it says the cross section has a width and a height. So we have this and we have this, right? However, it is a prism, it is a 3D shape. So it is asking me to find the length. We are going to tell this one is 9 centimeters and the height of it is 7 centimeters. Yeah, 7 centimeters. So it is asking us about the length. Yeah, what is this measurement? We know the volume of it is 693 cubic centimeters, right? Oh my God. It is with the exponent 3, so it is cubic, right? And we know volume is height times width times length. Now, in this case, 693 cubic centimeters. And we have two of these measurements, which are the height, is 7, the width, which is 9, and we don't know the length, but we have the result, which is the total volume, 693. So we can say 7 times 9, yeah, which is 63, yeah, times L, the length, is 693 cubic centimeters. And because of properties of multiplication and division, yeah, we can tell that because this is multiplying, it can come here to the opposite side of the equals, and it is going to be 693 divided by 63, now the length of it. And so, because we were allowed to use the calculator, we are going to say, where is the calculator? 693 divided 63 is 11. Yep. And so we are going to say the length is 11 what? 11 centimeters. So we have 1, 2, and 3, which means cubic centimeters. There in the answer, well, the volume, because our answer is this. All right? And that is exercise 6. Exercise 7, the shape below shows the measure of a cake. The shaded area needs to be covered with dark chocolate. I love dark chocolate. And the triangular shape will not have a cover. Calculate the area of the shaded region in the figure below. What we have here is two areas. We want to calculate the area of the rectangle, which is side by side. And so we subtract the area of the triangle, which is base times height, divided by 2. Now, let's calculate it. So the area of the rectangle is 30 times 28. Yep. We come over here, we say, then 30 times 28, yeah, 840. So this is 840 what? 840 square centimeters. I'm sorry, square inches. Everything is given in inches. So square inches, because we are talking about area. Area is given in square units. Now, the area of the triangle. What about that? Base times height divided by 2. Yeah, that's the formula. And we know the base is 25 inches times 22 inches divided by 2. How much is 25 times 22? We want to go like this, 25 times 22. It is 550. So 550 divided by 2. Yep. Well, although we don't need a calculator, we're going to say, what about these divided by 2? Yeah, it says, then it is 225. Yep, 275, I mean. 275. Well, in this case, square inches, which we are going to subtract from 840, right? Once again, the area of the rectangle minus the area of the triangle is going to be 840 minus 275. How much is that? 840 minus 275. It is 565. So we say the shaded area is 565 what? Square inches. Remember, no unit, no point. Now, just to double check. All right, and then that's our exercise. Yeah, all this area, now the dark chocolate is going to cover an area of 565 square inches. That was good. Over here we have this exercise solved. It says we had to organize these different concepts in this chart, whether they were quadrilateral, not a quadrilateral, whether they were regular shapes or irregular shapes. Yeah, regular means all the sides are equal. Then, having this vocabulary, we are going to say, let's make it a little bit smaller so we can fit. We can make it fit here in our screen. Okay, rectangle. Well, a rectangle is a quadrilateral, but is irregular. Yeah, not all the sides are the same measurement. So that's it. Let's go, equilateral triangle. Well, it is not a quadrilateral. And it says equilateral. It means it is regular. Yeah. Equal sides hexagon. Yeah. So I couldn't write here, regular hexagon. You don't normally call it equal sides hexagon. What you call it is a regular hexagon. Yeah. Of course, I wasn't going to write that, but then we have to classify it here. That's it. It is a quadrilateral? No, definitely it is not. And anyway, it is regular. So what about a kite? Well, a kite is a quadrilateral. Yeah, it has 4 sides, and it is irregular. Yeah. Can we have a regular kite? Well, basically, it will be a square. Yeah. Let's say isosceles triangle. Well, an isosceles triangle of course, it's not a quadrilateral, and it is irregular. A rhombus is a quadrilateral, and it is irregular, right? And we have a trapezium. The trapezium is a quadrilateral, and it is irregular. Not all the sides are the same. Then we have a scalene triangle, which is not a quadrilateral, and not all the sides are the same. Actually, all the sides are different. And finally, a square is a regular quadrilateral. And that's it. Yeah, we have to make it fit. So kids, this is the correction. I hope you have learned, and I hope you have had very good results in it. Okay, so have a good one. Bye bye.